Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain. I want to welcome you to this presentation on holistic order fulfillment with mobile robots, automating case-picking operations, presented by ForwardX Robotics. One quick reminder, there will be an audience question and answer session at the end of this presentation. Audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A icon at the bottom of your screen. So each picking autonomous mobile robots, that is AMRs, have been available for more than a decade, but cost-effective case-picking solutions have remained an elusive target. And the orchestration of multiple robotic form factors and processes requires significant effort and investment. That helps to explain why the goal of a holistic automated workflow for order fulfillment with mobile robots has remained largely out of reach until now. Today, we're going to showcase real-world success stories of companies integrating high ROI case-picking solutions into their fulfillment operations, and we'll learn how you can harness the transformative power of mobile robots in your outbound workflows. With that, I want to introduce our speaker for today. Chris Harbert is Sales Director with ForwardX Robotics. Chris is a 10-year veteran of the robotics industry, having also worked for companies such as Rethink Robotics, Locust Robotics, and Gray Orange. Born and bred in the Boston area, Chris is a proud father of three, and in addition to his unreasonable fascination with robotics and technology, is an avid traveler, theater groupie, and an amateur foodie. Your basic Renaissance man. With that, I want to turn it over to Chris Harbert. Chris, take it away.
Thanks very much, Bob, and thanks for everyone joining us today. I'm very excited to be here with all of you and to share this information with you. So today we're going to cover three main topics. One is new approaches in case picking and how mobile robots can be applied for that. The next is some key considerations if you are looking at exploring case picking automation in your own facility and operations. And then, as Bob alluded to, looking at some real world case studies and the ROI with metrics to give you a flavor of what you might be able to achieve yourself. So thinking about current, or you could say this is historical case picking approaches, there's three main variants, right? And they all have utility individually and in combination with each other. So you have your manual hand jacks. This is people pulling, pallets or stacks of cases, as you see here around. You have the more, I would say, advanced electric pallet jacks. So you have, less of the ergonomics issues that you have with the hand jacks. One of the detractors, one of the challenges that comes into play with EPJs is that they are significantly higher cost than their manual cousins. And then you have your forklifts, which again are furthermore in cost, very versatile, high speed. You don't have, really the same ergonomic challenges, but along with the cost, you also have safety considerations that really needed to come into play, because now when you have, many vehicles driving around, and you have that mixed with folks on foot and other types of equipment and product and what have you, there are some challenges that come up with all of these. So these are all good. They're all, tried and true standards, but there are challenges that come along with them. And then in addition to that, they do compound with into, I would say, more resource and process challenges, right? So on the front end, let's say, of the picking event, right, you have folks who are doing each picking. You may have folks doing case picking, like we talked about through one of the various methods. You may also have replenishment tasks. You may have audit tasks. These are all coming into the same space with each other, right? And so coordinating those tasks in an efficient way, avoiding congestion, prioritization of which comes first. This is really significant work. It takes a lot of brain power, and there are folks that we encounter with, and I've spoken to personally, who do a fantastic job of trying to manage all of this and keep the operation running smoothly. Then on the back end, you also have, again, sometimes challenges that come out of deconvoluting this. So you have consolidation. Let's say if you're picking to an EPJ and you're each picking to a push cart, and they have to go together before they go out to your customer. Well, so then you need a consolidation space and task flow and personnel to do that. Things like QA and staging for outbound. So it becomes very complicated for any operation where you have especially this mix of different types of picking modalities. So let's look a little bit about how mobile robots can be able to help support case picking specifically. So here you have two different examples. First is a pick to order. All right, so this is sort of your classic style. There is, this would be a substitution for someone on an EPJ or someone pulling a hand jack or even potentially on a forklift. The mobile robots pick up a pallet. They drive to different locations on the floor. The system is telling the robot where it needs to go for the various items. It's met there by a picker in the aisle. And once an order is complete and full, it brings it back in a pallet form to drop it off for whatever its next process flow is. Now, you can also have a different type of a flow, which is sort of a batch pick to a milk run type of style. So this would be if you were picking up an entire single SKU pallet and making several drop-offs at your dock. And that's what you'll see here. So in the left-handed case, we were using a flatbed style robot to pick the pallet up from underneath. In this video on the right, we just happen to be using a forklift style. This is an AMR forklift, and it's picking up in this cross-docking operation, picking up a single SKU of product, and it's making, as you can see, they have lanes in this particular facility for different trailer routes, right? And they have spots along each trailer route on the dock that correspond to different storefronts, right? And so instead of picking a whole order for one store and a go, like we saw in the first video, this is more of a, I'm gonna take all of a particular item and then I'm gonna drop off in stages, right? And that's really just because it's really to fit with however that facility is currently laid out and how that operation flows best, irrespective of the robots being present or not. And so thinking a little bit about, well, how does this actually produce any different results, right? So if we think about traditional picking, right? Let's say we have Tommy and Susie and Bobby, right? And they have each line color is representing one of those individuals, right? So they're going to get a task list of items to go and get in the aisles, right? Cases to go pick. And even with all of the optimization that does exist and does happen, there's still a fairly significant percentage of the floor that they're likely going to have to transverse, right? They're going to likely have to start close to, one side of the floor and make their way through, snaking through to the other side of the floor, right? So it's a decent amount of travel. Now, instead, what robots allow is for more of, I would call it a zone defense style, right? So instead, Tommy and Bobby and Susie, they're each going to have zones, and they're responsible for their condensed part of the floor. So they don't go from end to end. They stay in a handful of aisles. And the robots instead are doing the transportation between the different zones. So the robots are taking the items almost like a pick and pass type flow, and they're moving from zone to zone to meet up with Tommy and Bobby and Susie. And what that does is that allows your staff to spend a much lower percentage of their time walking from place to place, and therefore a much higher percentage of their time actually filling orders. And that leads to some fairly significant increases in units per hour, or UPH. And you can see, we see ranges of anywhere from 50 to 200% increases. And we'll talk a little bit more about that later on in the show. And really what this also comes down to, besides the direct picking percentage time, right? Or the reduction in walking is how it's sometimes referred to as well. You really also have the opportunity to try to optimize your staff's time when they're in the aisle, right? Because by using robots who might be coming in with different form factors or different tasks, your average Joe, pardon the pun here, each time Joe goes into an aisle, the robot system, together with your host system that may be directing traffic or directing task prioritization, you might have Joe picking eaches onto one robot. That's going to then take those and go to the next item location. You have maybe a different robot coming with a pallet, and Joe's going to do a couple of cases for picking. And then you might have a replenishment task that's coming in while Joe's in that same aisle for put away and replenishment of active stock. And there may also be some auditing tasks or cycle counts And all of this can be coordinated so that when Joe goes into that aisle, he can perform 1, 2, 3, or 4 different types of tasks with one visit, instead of having to send an each picker on their route and a case picker on their route and someone bringing replenishment on a forklift and then sending a tire team to go into your audits. That's 4 trips to the same location. Instead of being able to try to coordinate all of those, let Joe do the really valuable tasks of picking, replenishment, cycle counts, auditing, what have you, and let the robots do the lower value added task of just moving the goods from one space to another. So now that we addressed that a little bit, let's talk about what you want to look for if you're thinking about trying to automate your case picking operations. There's a few things here that really do matter. One is technology. Now, as Bob mentioned, AMRs have been around for over a decade, but they haven't just been static over that decade. Like anything, there's been tremendous advances in terms of the sensor capabilities and the abilities of these AMRs with those advances in sensor technology and software processing and what have you. And here's an example. So every AMR that you're going to find in the marketplace is using something called LiDAR, right? So that's using essentially a sophisticated laser pointer and scanner looking for objects in the field that it doesn't expect to be there, right? And at ForwardX, we use that as well. But you can see here an example where this system is combining not only LiDAR, but machine vision. And this is both 2-dimensional machine vision and 3-dimensional machine vision. And by combining all of those, what's able to be achieved is not just the detection of something that might be in the way of a robot, but as you can see in the top left corner, actual recognition of what that object is. So in this case, you can see that this is the robot's view. It's seeing that that's another robot, and there's also a person there. You can see the lines, the colored lines, where it's denoting the tracks. It's actually seeing the racks and separations in those, right? And why this matters is because the more granular, the more accurately a robot can see the world, the more appropriately it can behave in that world, right? And so if it sees a pallet on the ground, if it doesn't know that it's a pallet, it has to treat it like it's the worst or most dangerous item it could be, right? And that's usually for robots, that's usually a person or a forklift, right? Because it's usually a safety consideration. But if you know that it's a pallet, then you can go around it at full clip because the robot is programmed to know that that pallet's not going to move by itself. Even here, you can see the robot's coming up on an intersection, right? So it's knowing to look because there might be cross traffic. And in fact, it notices the tines, just the tines of the forklift, and recognizes that, oh, there's a forklift coming, and it behaves appropriately. It slows down to a stop, right? Because a forklift and a robot don't mix very well in the aisle, right? And so this does a couple of things. One, it increases the safety profile of robots on your floor, right? Because they recognize not only that something is there, but what it is, and they can respond appropriately. But the other thing is that it actually does 2 other things. One is that it allows for a higher level of positional accuracy by combining all of these different sensors. And you can see an example of that playing in the video below, where now this is a lab type setup, right? Full disclosure, right? But you can see this is a 0.8 meter aisle. So that's about 32 inches, give or take, right? Because there are these combination of sensors and then the algorithm that's processing that data in real time on the robot and the system that's managing it, the fleet manager that's managing it, knows where that robot is within 10 millimeters. So that's about a fourth of an inch, right? All the time. And so because of that, it can navigate even at realistic and productive speeds through very narrow traffic areas, right? And so we have sort of a maze that's built up here. And then you can see, even when you think about something that's a little bit more realistic, having racks with cases of goods on there, very narrow aisles type setups, the robot's able to navigate through that successfully. And what this culminates in in a real world environment is what you see on the right here, right? So this is a robot carrying a metal push cart on its back and coming through what I would argue would be a robot product team's nightmare and an operational manager's average Tuesday, right? This is the real world as it exists. There's carts, there's people, there's pallets on the ground, there's things placed on top, right? And so this combination of sensor technology and all of the brains behind it, as you can see here, right? We have a wooden pallet on the ground and a plastic pallet askew. Now, the robot took an extra half a second to navigate around that and make sure it didn't clip anything and didn't bump into anything. But it did it successfully and without intervention. And that's really the core message here, is that this technology, yes, it improves safety, and that's, of course, paramount in any operation, but it also ensures that the robot gets the mission done and doesn't get stuck, doesn't get stranded, doesn't need your folks to have to leave whatever valuable work they're doing to go and take care of the robot, right? And that's really why this technology and how it's advanced over the last decade and is now available is a game changer in real world productive operations. Okay. Second thing that matters a lot is flexibility. And the reason behind this is that if you've been in operations for any length of time, or engineering, or just in the industry, you know that no two facilities and no two operations operate the exact same way. So being able to have solutions that can meet your operations as they are, right, without forcing a significant amount of change, is very important for it to be practical, right? Because if you think back to the early days of AGVs, right? The early days of AGVs, and some of us might be, including myself, I'm putting myself in that camp, might be old enough to remember that you had to dig a little tunnel and put an electrical wire in your floor, right? So you had to dig up your concrete, and then you had a track, like an old school trolley. And that was where that robot was going. It didn't come off the track. You couldn't make changes. If you needed to change the direction or the path of the robot, that was a lot of change for you, right? That was a big infrastructure investment and change. That's not the case anymore. Now we have these AMRs that don't need guides. They don't need wires. They don't need QR codes on the floor to know how to get from A to B, right? And now this is expanding that flexibility even further, where the same types of robots can be used in different types of floor layouts and interacting with different types of equipment, and also can perform similar functions with different form factors. So we already saw a couple of examples where we were case picking onto a flatbed robot or case picking onto a forklift. And there are real reasons why you might need one or the other, or maybe both, in any given operation. And so having this kind of flexibility of different form factors that can perform the same type of function or category of function means that you don't have to change your operations to fit the automation. And then the third major aspect, and these are just, I would say, the top three from our perspective, is experience. Now, at ForwardX, we feel very fortunate that we've been invited to serve over the last 7 years a number of household name brands all over the world. This is just a sampling of them, but this is really something that, when you look for any provider for this kind of automation or automation in general, you want to make sure that they have the experience of serving real world operations just like yours. All right. Now let's get to the fun stuff. Let's look at some real world examples of this. So here's an example of picking to pallet, both batch picking and ship alone picking in an e-commerce environment. This is a company called Gatu. They serve a number of different industries. They're a third-party logistics provider. They have a lot of automotive aftermarket style products. However, they service a number of different industries. In their case, they had previously been picking to forklifts, as you see here, or to hand jacks. By bringing in these mobile robots and getting that zone defense style of picking with this, they've seen over an 80% improvement in their units per hour, or UPH, and their accuracy is up to 99.99%, right? And if anybody's had any issues with returns, returns or errors in terms of your picking and penalties that correspond with that, you know that getting to that 99.99% is not only a money saver, but it's also a customer relationship saver. And that's one of the things with Gattoo, is that they are very dedicated to their customer experience. And so using these robots helps them fulfill orders accurately the first time and hit their customer SLAs. Here's another example. This is JD.com. And for anybody who is not aware of who JD.com is, and I wasn't until somewhat recently, they are Asia's version of Amazon, but bigger, right? So JD.com services somewhere around 580 million customers in the Asiatic region, from everything from B2B to direct-to-consumer flows. In this particular facility, this is, as you can see, a food and beverage style facility. This is an e-commerce warehouse where they're shipping cases of Coca-Cola and Pepsi and everything else under the sun. They used picking to these robots, similar to picking multiple orders actually to one robot. So the robot has a bunch of different orders it's going to go get, and then it brings all those orders to a downstream conveyor. And this was already existing infrastructure. So they already had the conveyor there before they brought the robots in. They were just picking to hand jacks and electric pallet jacks, right? And so people were getting tired. They had errors that would occur because, you know, it's difficult and it's heavy lifting ergonomically. So JD.com in this facility, they saw 133% improvement in units per hour during their standard times. And then they go through holiday peaks, just like we have our retail peaks. They go through holiday peaks. They saw a 400% improvement during their peak. And part of that was because there's always a challenge that comes with bringing in temporary labor. They don't know the system as well. They're not as experienced. And so they saw even greater improvements during their peak period, along with a 90% reduction in errors, right? And this is phase two. So the phase one, you saw there was a gentleman who was taking the product off of the robot and putting it onto that conveyor. That conveyor is going downstream to different pack lanes, and they're getting loaded in floor-loaded LTL shipments. Here, they've actually put in a robotic arm in phase two, where the robot shows up, the mobile robot shows up with cases. They have a camera overhead, and the robotic arm is picking the cases off of the robot. So they've even taken the ergonomic strain of lifting those cases all day long onto that conveyor away from their staff, right? And now they have a robotic arm that coordinates with the mobile robot to get this all done. And then our third example for the day, this is DHL over in China. This is a case picking operation for a coffee retailer. We're not allowed to tell you which one it is, so sorry for that. However, this is, you can see how they were picking previously, right? Hand jacks on pallets, and their flow is not a pick to order flow. Their flow and the way they've set up their operation prior to bringing in any robots was a batch pick to milk run drop off. So here you can see in their space, in their facility, the aisles are a little narrower, right? So while they could have used the flatbed robot that we saw in the previous video, or a forklift like we saw earlier in the presentation, they wanted to use something that was a little slimmer and sleeker to make sure they didn't run into congestion and they didn't have too much traffic and getting in people's ways. So they used a different robot form factor still to do case picking, and because that fit better with their facility. And so here what they're doing is they're getting orders, and they do this every day. So they have daily replenishment to over 600 coffee shops in their region. And so, as you might imagine, they get all of the French vanilla beans for today, right? And they put all of that on one of these shelves. And that's not a built-in shelf. Actually, sorry, that is a built-in shelf in this case on that robot. And then the robot will make different stops if you saw the number of pallets with the red totes, those are their routes. Those are their delivery routes. So they put all the French vanilla on the robot, and then the robot stops off at each route based on the orders for that day. And in this operation for DHL, they saw a 200% improvement in their units per hour. And again, a 90% error rate reduction, and they saved 43% in their labor costs, because it was so much more efficient to let their folks do picking in one aisle, and then another robot comes very close to them, right? And they can pick the caramel beans to the second robot, right? So you have this swarm effect. So hopefully that gives you a flavor of some of the results that companies are having employing this kind of case picking automation.
Thank you so much, Chris, for that great presentation and some really impressive results there from the use of this technology. I'm going to assert the privilege now of asking you a few questions for the panel discussion portion of our presentation, after which we will take audience questions. And I do want to remind the audience that at any time during our discussion, you are certainly encouraged to submit your questions by clicking on that Q&A icon at the bottom of your screen. But anyway, in the meantime, Chris, again, you make such a great case for this technology, but at the outset, at the top of the show, we noted that there have been some reluctance on the part of facilities to adopt it. So what has held back advances in case picking automation until now and recently?
Yeah, that's a great question. I think from the conversations that we are privileged to have with operations around the world, what we hear most commonly is that it's been limitations in technology, right? So the advances that we were talking about with the machine vision, combining with the LiDAR, and being able to detect what objects in the space actually are, that's relatively recent, right? In terms, it's that wasn't available a decade ago. And then how that relates to the navigation of those systems, the safety of those, especially as we think about some of the larger form factors like the AMR forklifts, right? Those are large machines, right? And so there's a safety element that's extremely important with those kinds of systems, and then also the cost, right? So taking advantage of Moore's law and the ever improving, I would say, cost of sensor technology, and then also the general state of knowledge and understanding of how to integrate those different data feeds into something that is discernible and practical for an operational floor. So I think those are things that have held back advances until now.
And I wonder if to some degree perception hasn't caught up with reality in terms of the safety factor of this technology. What you showed us there, it seemed to be the safety seemed to be quite good, but people could still get a little nervous looking back to the days of so-called caged robots when they were kept, completely separate from people. And obviously, that's no longer the case here. So interesting that you should make that point. Thank you. Okay, so on the other hand, there's definitely an urgency out there for facilities to begin looking at this technology. So what are some of the macro factors that you think that are contributing to increased pressure on picking operations?
Yeah, I mean, that's also a good question. So, anyone who's out there in the trenches knows that the landscape has been changing and evolving almost constantly, right? Labor is more difficult than ever to not only to cost justify and support, but even to find, right? As an example, and unfortunately, customer expectations have not slowed down, right? So, when we think about, for example, in North America, when we had the pandemic, at the outset of the pandemic, there seemed to be sort of a collective, okay, we understand that what used to be next day shipping is now going to take a week. And everyone understood that for about 3 months. And then we all got tired of waiting for a week for our toilet paper to show up, and we wanted it next day again, right? And so, and that's sort of a growing trend of, you see that in the kind of SLAs and the moves in retail with BOPIS and its growing, insurgency with that, and the sort of constantly shrieking delivery times that are becoming sort of table stakes for any provider, right? For any product manufacturer or provider. And so, because of those sort of macro effects, there's even more pressure on operations to hit your SLAs, to to keep your customers happy, to beat out the competition. And then that's all while simultaneously dealing with more and more SKUs than we've ever imagined having, right? There's just a SKU diversity explosion that doesn't seem to have an end yet. And especially with all of the new e-com players and platforms like Etsy and others where Amazon Ship Services and all this kind of thing. There's all these tools for folks to have an offering that's valuable to the marketplace, and it's a fantastic time to be a consumer. It's probably the best time in history to be a consumer, but that comes at the price of the pressure and the strain on fulfillment operations.
For sure. Okay, with all of that in mind, Chris, how have picking operations actually changed? The nature of picking operations changed fundamentally post-pandemic, and I use that reservedly, hoping that we're in post-pandemic, but if that is indeed the case, how have picking operations changed?
Yeah, I mean, I would say, 5-10 years ago, when talking with folks about their picking operations, and whether it's about automation or not, it used to be more of a profit chase, right? Well, how can we do this most efficiently and make sure we're getting the most out of our bottom line? And in the last several years, it's really not that anymore. It's really, how do we keep up, right? How do we not lose customers? How do we maintain market share? Of course, if there's an opportunity to leapfrog ahead and become, more competitive, that's beneficial. But folks just aren't coming back to the warehouse floor. They just aren't. And so, as unfortunate as that is, I mean, the labor shortage isn't getting better, it's getting worse. If you look at polls of different demographics, right? As much as the industry does, and there's a lot of great work happening to instill excitement around supply chain, around fulfillment and logistics for young people, fewer and fewer of them are coming into the space, right? And so the average age is increasing every year, and that just presents a significant challenge. And every operations manager I speak with they're asked every year, every month, every quarter, how do you do the same or more with what you have or less?
I just saw a report today saying that the so-called Great Resignation is over, but unfortunately, it sounds like that hasn't quite translated into the warehouse floor.
No, not yet, unfortunately.
This is going to be an endemic problem you're going to be dealing with going forward, which of course is why we're having this great discussion about automation as an approach to addressing it. Okay, so you did a good job of explaining to me why the advances in automation have been a little bit slow in taking hold. But maybe I should drill down a little bit more and just kind of give me, what is the feedback from your customer base, your potential customer base, as to the biggest hesitations that they voice to you with respect to exploring automation?
Yeah, well, that's a good question. So I think first and foremost, and we just sort of have to call the elephant out in the room, right? These are mission critical operations, right? Your fulfillment stream is your revenue stream for your organization. It's your lifeblood. If you can't ship product, you don't have any money to pay anybody's salary, period, right? And so there is a very valid and very high level of skepticism and conservatism when it comes to making any kind of changes to an operation, right? And specifically around bringing in equipment, whether it's robotics, whether it's conveyor systems or whatnot, of what promises or what I would say contingency plans do I need to plan if I'm an operations manager if this thing fails? So the risk of system failure and the impact that might have, and the sort of corresponding expected dependency, right? What if I bring in these robots and everything's going great, but now it's Sunday after Black Friday, it's 2 a.m. and everything shuts down, right? Because every operations manager I've ever worked with and known has had one horror story or another, whether it happened directly to them or somebody they know, that they brought in a new, whatever it was, software, widget, scan gun, new kind of technology, and something went wrong, right? So that is sort of I won't say it's no wives' tale, because unfortunately, there are plenty of real world examples where failures have occurred and they've hurt people's, livelihoods and businesses. But this is something that's so sort of pervasive of it's sort of, okay, well, what happens when it all breaks, right? And so that creates natural hesitation, right?
What we're doing is we're going from Moore's law to Murphy's law. It's basically what's happening here.
That's exactly right. That's exactly right.
Yeah.
And then I think in addition to that, there is, and this is, I think to your point, maybe a perceptional change that needs to sort of sweep through the industry, is historically automation was a big upfront investment, right? Because automation used to mean I'm going to put in 16 miles of conveyor and 4, automated lifts and whatever, and I need a check for $10 million to get started, right? And that's just not the case anymore. But there is that hesitation because maybe the news hasn't traveled far and wide yet that you can get into automation at a much more reasonable initial investment.
And not just in terms of the cost, but the flexibility of the operation. I mean, you
That's right.
assure these companies that they'll be able to scale up and down in accordance with the season, in accordance with changes in demand, that they won't be locked into a system that is not appropriate for something to happen 6 months from now.
Exactly right. And it's an excellent point to make. That kind of planning used to be on the 5 to 7 year horizon, right? You'd sit down and say, okay, where's our business going to be in 2030, right? And the rate of change in the marketplace and in the world in general, right? Nobody has a crystal ball that's better than 6 months now, right? And so thinking about that, well, how do we plan? And I know folks that they had a big investment and they spent hundreds of millions of dollars in some cases on something that was supposed to last them 8 years, and 3 years later they were at capacity, right? And what do you do then if you're tied into that fixed infrastructure? If you spent all this money and it's still not enough because the world changed, right? And we saw that with the pandemic, as well, of sort of store.
Or if the opposite happens, if demand temporarily goes down, you're suddenly stuck with all these units sitting around and paying, supposedly paying for them, and they're not yielding the ROI you wanted. But this allows for a level of flexibility that avoids that from happening. Let's talk task orchestration. I'm curious as to what you see as the fundamental difference between task orchestration approaches that use people and allowing automation software to run the show.
Yeah, so this one gets really interesting, right? When you go to especially very efficient operations, and you drill down, you will often find, not always, you will often find there are critical folks with tremendous experience and skill, and a high level of what I would call tribal knowledge, right? You have Jenny, who's your wave manager, and she just kind of knows because Jenny's been doing it for 8 years, right? And so she has an innate feeling. It sort of gets into her bones, as we would say sometimes, right? And that's fantastic. And Jenny is an amazing asset. And what happens when Jenny's sick, or Jenny gets a new job, or what happens, right? And so you see that dependency occur. So that's one aspect of it's really current task orchestration is a really complicated thing that there's a varying degree of skill with which it's executed in operations today. The other side of it is that as we add more and more types of let's say purchasing avenues for end users, right? So even in, say, B2B type marketplaces, I know a lot of automotive tier 1 suppliers, right? 15 years ago, if you were supplying Chrysler with parts, you got to have a 5,000 or 10,000 unit order minimum, right? And you could send it in batches, and Chrysler would figure out how to do that. And I'm not picking on Chrysler specifically; they're just an example automotive manufacturer, right? Nowadays, if you're a tier 1, tier 2, even a tier 3, your demand from your OEM is that you will deliver segregated parts in a specific order that you receive 48 to 72 hours in advance, right? So that now you, as the supplier, have to manage. Well, if you need to build it in 10,000 part increments, that's your problem. You figure out what to do with the 9,527 that I don't need in the next 72 hours, right? And you deliver it to me right when I need it. So how that comes into play with all of this is that you have a much lower threshold for purchase. And that's true in e-commerce as well as it is in B2B. And what that complicates is that now I have more and more variation in terms of my quantities that I'm picking, right? So I have an ever increasing flux between cases, interpacks, multiple interpacks, eaches, and they have to be combined in different permutations, because we're enabling our customers to buy as they want and how they want and when they want, right? And so the sheer number of possibilities and the variation of tasks between eaches picking, cases picking, interpacks, coordination, consolidation, auditing, replenishment, all of that stuff, it gets to a point where it's really, even for the most skilled human mind, it's incredibly challenging to try to orchestrate that optimally in environments and operations where things change day to day and hour by hour, right? So it's just the computational brain power, even though humans are fantastic at this, it's really extreme. And so by having automation systems that are designed for this, they're designed to look at trends and takt times and current status and whatnot, and be able to actively monitor hundreds, if not thousands, of different variables simultaneously, it gives a lesser strain on your staff so that they can still be extremely efficient and effective without having, to have 16 cups of coffee a day.
Yeah, well, it just seems like the conclusion here is that task orchestration with automation is just an absolute essential element in today's modern day omni-channel warehouse. I would like to bring the audience in at this point. We have a good number of audience questions that I want to ask you, Chris. So let's do that. And even as we're doing that, I want to remind the audience that you can continue to submit your questions as we are answering what we already have, and we will get to as many of those as we can, time permitting. Looks like a basically yes or no question. This person wants to know, are you using your own robots? And if not, which vendors, and how do you choose your vendors?
Sure. At ForwardX, we do produce our own robots. In fact, we have internalized almost 95% of our entire supply chain. That's, as an organization, that has been our choice, mainly to ensure our own flexibility and ability to hit our customers' deadlines. So our lead times, lead time is something that has been, I would say, scope creeping for most suppliers over the past few years. And we really want to counter that trend. And so we make just about everything that we can make, even down to things like the wiring harnesses that go into our robots in-house.
Yeah, okay. The questioner wants to know what the role of labels are or is in this new automated scenario. Labels, of course, are essential to an operation. Where do they fit in?
So labels are still very important, right? It's one of, I would say it's one of the easiest ways to ensure accuracy in your pick process, right? If something has a label on it, you can scan that label, you can, sort of instantly obtain and verify that it's the right item. That said, we work with a lot of operations where they have some number or population of their inventory that's either too small or too precious to have a barcode on it, right? And so in things like that, we are seeing more trends towards, I would say, a more digitized type of tracking. So things like RFID. As an example, all of our robots at ForwardX, they have RFID readers on board by default. And so not all of our clients use it for that purpose, for tracking or counting or scanning or whatnot, but it's there. And part of that is to help make sure that we're staying up with the trends, right? And so and hopefully I understood the question properly. I assume that when the person was asking about labels, they meant barcode labels for product.
I assume that as well. Yeah, I think that's what they were talking about.
Yeah.
I think we might have an answer to this one just from having watched the videos, but I'm going to ask it anyway. And the question is, do these robots adapt for packaging sizes and shape variances?
Yes, so they can. In fact, we do have, and I apologize for the background noise here. We do have the ability within our software to handle the cubing of orders and configuration of different packages onto any particular robot mission. That can be directed to us, but it's not required that it be so.
Thanks. The questioner here is asking about the ratio, the number of pickers to number of robots for the scenarios that you have presented, and what was the original number of pickers that was involved prior to this. I see we're moving to a more advantageous place in terms of noise, are we not? I have to give you a moment to do that.
Just moving so that I can hopefully hear and be heard a little bit better. Sorry about that.
That's no problem at all. We are facing the real world in every possible way. So again, this whole question of ratio of picker to robots and what it was like before, can you address that?
So yeah, in terms of pickers to ratio, it does vary from one operation to another, and that depends on kind of the order profile and how that mixes with their level of inventory. So as an example, we work with operations where it's a classic Pareto type of inventory, right? 80% of your outbound volume is coming from 20% of your goods, right? In those kinds of operations where you have, dynamic, whether it's dynamic or at least system guided or intelligent slotting, right? You might have a robot to picker ratio of maybe 2 or 3 robots to picker, right? In other types of operations where it's more of you have a much larger inventory base, much larger SKU count, and a much, I would say, flatter Pareto analysis, we might employ a different kind of strategy where instead of having defined zones and everyone sort of has their number of aisles that they're static, we can do things like a sweep kind of motion where you still have zones, but those zones migrate over the course of the shift. And so in those kinds of operations, and we do have in some cases, there is a more closer to a 1-to-1 style ratio of pickers to robots, because it's not exactly 1-to-1, and it doesn't mean that the picker is always associated with the same robot. But if you have 4 pickers sweeping a warehouse, you might have 4 or 5 or 6 robots depending on the volumes that you need to support.
This questioner wants to know if similar types of robots are being developed for retail. I assume that he's talking about, can they be on the floor of a brick and mortar operation? A robot, for instance, that might bring a customer order at your local Whole Foods or something like that.
Interestingly, in some parts of the world, we have already seen some of our robots being employed in store environments. Now, I think the timeline for that, at least in North America, and I would argue most likely in parts of Europe as well, is less about the capability of the robots and more about the customer sentiment and their end user customer sentiment as well. Not everybody likes the idea of having a robot that drives around by itself, out on the floor. And so, the good news is that for those operations that want to explore that and they're comfortable with it, and they think that their customers will be as well, the current level of technology is able to largely support that.
I'm betting that customers or shoppers are going to get used to that type of thing real fast in the next few years. It'll just be second nature. Yeah.
I think you're right.
Good question here. What challenges do you have with integrating these AMRs to a legacy WMS, warehouse management system? And I guess I might extend that to warehouse control system, warehouse execution system, or any other legacy systems on board that you have to somehow integrate all this together. What are the challenges there?
Sure. There are challenges, right? And I would say the challenges come less from the robot maker's side of the floor, right? Mm-hmm. And that's not throwing shade at anybody here, but I think we all know that the WMS, WCS, WES landscape has been highly fractionated for the last decade, if not more, right? Everyone has their own unique specialized instance of Manhattan, right? Or high jump or JDA or what have you, or they have homegrown, right? And so that usually is where I would say the challenge comes into play, of making sure that all of the information relays and connection points are tied off and that they function as appropriately. Now, that being said, what ForwardX and a number of other providers, automation providers, have done is really to focus on having a very comprehensive and streamlined API layer, right? So that it's straightforward on at least one side of the knitting exercise, let's call it that. And to a certain extent as well, at least in ForwardX's case, we've built up within our vertical software stack a number of different modules. So it's not only a fleet manager that's handling the robot tasks. There's also an order management module that comes along with. There is a task and a task orchestration engine between either different tasks, functional tasks between auditing and picking and replenishment and what have you, as well as between different robots. So coordinating sort of a sequence of events based on triggers, whether they be physical triggers, like somebody hitting a button at the end of a production line or at a pack station, or whether they be virtual triggers based off of, okay, I know that this is a replenishment function and I have a pick function at the same location. The system understands logic enough to understand, okay, I have to finish my replenishment before I can go pick from there, right? Because I don't have any inventory right now, right? And so those kinds of orchestrations are things that are pre-built within our software, and we're not the only ones that have those kinds of modules in there.
Right. Here's a question that addresses the opposite problem that we talked about earlier in the presentation, where we talked about why are some companies holding back on adopting this technology. This questioner asks, how can companies interested in implementing automation avoid the so-called jump into the deep end of the pool? where you kind of like go all in on it, and all of a sudden, oh my God, we're drowning. How do you avoid that?
Yeah, that's a very good question. So, I mean, my suggestion there would be for all the potential suppliers or partners that you speak with, make sure that they are aligned with a sort of crawl, walk, run approach. So the different kinds of purchasing models, as an example, a lot of AMR companies, including ForwardX, we have both CapEx, traditional CapEx where you buy the equipment. And then we also have a robots as a service offering where you subscribe to it and it's more scalable. But even with that, these types of systems are relatively straightforward to take a small chunk of your operation and introduce the robots into just that chunk without disrupting the remainder, right? And so you can test in a small batch. If and when it works, you can scale up very quickly, right? As opposed to, and again, ASRS are fantastic and they serve great needs, but if you put a big box in, you put a big box in, right? And it's, you're handing over that multi-million-dollar check. With AMRs, it's a different style approach. You could start with a handful of robots to test out in part of your flow and prove it out and see some value first before you make a bigger jump.
Mm-hmm. As we know, executives are asking for a much quicker ROI these days anyway. They need to see benefits pretty quick.
Yes.
So I'm taking, do you see a benefit of having different robot form factors that can perform the same functions, such as case picking?
We do. And I think, this really comes back to the variety and the diversity of different process flows, operational flows, and facility layouts, right? And so this some of it comes back to, it used to be, well, are you a brownfield or are you a greenfield project, right? And for certain types of automation, historically, if you were a brownfield project, that presented a real problem, right? Because if you're going to bring in a bunch of fixed infrastructure, there's going to be a high level of disruption that's going to happen to your operations if you have to coexist. It's kind of like if you're going to remodel your house while you're living in it, and you got to take out all your kitchens and bathrooms. Well, you got to be really smart about how you do that, right? Otherwise, you're going to have a really rough time. With having different form factors, it's more of you have the opportunity to come as you are, as a facility layout, as an operational flow, and choose the robots that best fit from a congestion point of view, from a weight capacity, payload capacity, things like that. You can pick and choose what makes most sense for your existing operations without having to change everything to fit the robots.
Interesting. The early days of the type of technology was really adjusting this system to fit the technology. Now we are very much in the phase where it's the other way around, and that really is how it has to be. Thanks so much for that, Chris. Hey, I got bad news. We are almost out of time, and I apologize for that, audience, because we've been having some great questions and a great discussion, but we have time for just one final question, and here it is, Chris.
Right.
If there was one message that those of us attending could deliver to the would-be naysayers in their organizations about exploring this type of automation, what would it be?
That is a good question. And there's no shortage of potential naysayers, I would say. I would say there's two parts. So the first part is that technology really has changed. And for anyone who their last look at the landscape was more than even a year or two ago, it's worth it to take another look, right? It has not been a static pool. It's not been a static environment. There have been significant advances, recent advances that warrant taking another look at this type of technology and applying it to case picking operations or picking in general. And then the second piece of that is, I would say, especially for the naysayers, proof is in the pudding. Get together with a supplier, get together with a partner that you trust, and get an assessment, right? There are a number of companies that will come in and they can help work with you to find out and examine your operations, come and visit your facility, and discuss in detail with you and help you determine your automation readiness as it exists today. And then also what the potential benefit might be if you chose to move forward and really implement some of these types of technologies. So, realize that the world has changed and get somebody to help you take a good look at it.
Chris Harbert, thanks again for that fantastic presentation, really exploring some of the nuances and the complexities of robotic picking automation, where it is today, and why companies should be giving serious thought to adopting it now at a time when it's more needed than ever before. So I want to thank you, and I want to thank our audience too for your excellent participation and your questions as well. Any questions that did not get answered by Chris because of time considerations in this presentation, I'm sure Chris would only be too happy to address them offline. So hey, listen, here's a special offer for viewers. ForwardX is offering a free automation assessment for Supply Chain Brain subscribers, in which our consultants visit your facility, evaluate operations, offer insights on future automation potential in the way we've been talking about today, and a complete customized report for you at no cost. So check that out by emailing chris.harbert@forwardx.com using the subject line SCB. In addition to that, audience members, don't forget you will be getting a URL for an on-demand share that allows you to watch this presentation for 30 days. So once again, thank you, Chris. Thank you, audience. Thanks, everybody. And everybody, have a great day.
Thanks so much.